Good morning, everyone. So you have got now today. We would like to have a consolidation on bonding and structure again. So, last last night we just drafted through a notes. I do think that it is just a brief note, and you need to do is to further elaborate and further add what you need. It is very important in to make your own notes. So this is what I would like to remind all of you. So anyone who have started drafting the notes, okay? If so, you please put a tick for here, and you still haven't started, okay? So please put a cross. I said before, you guys need to start drafting your own notes. So here comes planet Earth, and then and also it is the bonding and structure, the planet at the microscopic world one. Just two of you. How about the others? How about the others? Not yet. I try to repeat my questions. How many of you have started drafting your own notes? If yes, put a tick. If not, put a cross. Now, well, just few of you, okay? For the others, could you you have to work hard. Now, today, I would like you guys to have a look of the assertion-reason type question. Take a look on this. Now, try to recall your memory about this. Okay, so or you want to start from planet Earth first, or Michael one. Now, for each chapter, right, we have got some assertion-reason type question. So what is that? It's a very good way for you to start studying the questions. Try to see that you are try to see if your conception is still okay. So do you still remember what is a recession type question? What is it about? Choice A, choice B means both statements are correct, while A is the second statement can explain first statement. While statement 3, what was for choice C is cross and tick, while the statement for both they are crosses. Do you still remember? Now it's time we have got some students here, so it's time to have all of you, right? You can either turn on the mic, or you would have or you just type it to show me your thoughts. Now I start from the first one. Lei Long, are you here? Lei Long, question 1, this one. Now could you please start from this? Can you see that? Can you see this question? Now take a look on that. Hydrogen has no isotopes. All hydrogen atom consists of protons, electrons, and neutrons. What is that? It seems like Form 3 stuff, isn't it? Form 3. Do you still remember what is that? Statement 1 We have got two statements. Okay, we have got two statements. You have to tell me it is A, B, C, or D. Both are false. No isotopes is not correct. So can you tell me what are the isotopes of hydrogen? All hydrogen atom consists of proton, electrons, and neutrons. This is also wrong. How many types of isotopes do we have for hydrogen? Do you know? How about the others? 胡嘉倫 Hi, 胡嘉倫, are you here? Now, you have to further tell, right? Those explanation parts. The next guy will be, yes, D, I know. So you have to tell me what's wrong with it. And then you have to tell me the correct answer. Now, for example, I give you the first example. Now, hydrogen has no isotope. It's wrong. How wrong it is? Indeed, we have isotopes. We have three isotopes: hydrogen 1, hydrogen 2, and hydrogen 3. Okay, so you know that we have got some another name of hydrogen 2 is deuterium. This one is tritium. Okay, you know it. And how about this? All hydrogen atoms consist of protons, electrons, and neutrons. This one is not correct. So we have got some exception. So what is the exception? The exception, it is hydrogen 1, in which we have no protons. Okay, but no neutron, sorry. No neutron. Okay. So what wording so you type it? No proton, neutron. Okay, so remember. Okay, we've got just one proton, one electron, but no neutrons. How about number 2? Sulfur is a non-metal. Sulfur is a solid at room temperature and pressure. Okay, we're gonna tell me that was a second statement. A, B, C, or D. B. Okay, yes, both are correct, but they are not set as the answer for one and another. I'm sorry to say that I need to widen it because I need to write something on it. Is it better? Oh, so strange. It doesn't matter. I know because I just widen it such that you cannot see it. Is it better? Okay. Now this one this one's D. How come it doesn't work? Let me see now. Yes, this is B. Yes, that's right. This is D and this is B. Both are correct. Okay, but you cannot explain. How about number 3? The mass number of an atom is the sum of the number of protons, neutrons, and electrons. All atoms have protons, neutrons, and electrons.文希, your turn. You just write down C. You know that the first statement is not correct. So could you please change it? The mass number. What is that? It's an atom is the sum of protons, neutrons, and electrons. How wrong is this? Can you correct it? What's wrong with it? Protons and what? Neutrons, okay? Electrons. You need not write it down. So the second statement, all atoms have protons, neutrons, and electrons. Is it correct? Now, just like this one, hydrogen 1, we've got one proton, one electron, but no neutron. So this is the exception. Okay, 例外。Okay, so which is not correct. So the answer is D. Do you understand now? 文希, you understand now? The next guy is Chen Junhei. Isotopes of an element has the same mass. Isotopes of an element has the same electronic configuration. Chen Junhei, are you here?
A 除R 係壓嘅。
Sorry, statement 1 is correct or not correct?
1 correct, 2 not correct.
Oh, the first one.
The
first one
correct.
The first one is correct. Second one is not correct. So which choice is it? A, B, C, or D? Or neither? No, none of them. Now, indeed, remember, I just recall your memory about choice A, B, C, and D. Choice A, B means both are correct, okay? But the statement 2 can explain statement 1. While C and D, C is cross and tick, while D is both are crosses. But we do not have any combination of tick and then cross. Okay, we do not have such a combination, no. Now, indeed, we have got the OCE MC, we have got that statement. Do you know it? If you have got OC third level MC, we have got either the statement will be either one is wrong, which means it can be cross tick or tick cross. So remember, for DSE or the and later on for the third level exam starting from 20, as I remember, that should be 2005. Yeah, that should be starting from 2005. Even that choices will not appear. Okay, we do not have that one and forever. Okay, so until we have got a new arrangement. Same 2005 from now, we do not have this, as I remember. So take a look on that. The first statement: isotopes of the elements have the same mass. The answer is wrong. Okay, why? What is meant by isotopes? Definition, please. Any definition?
Isotopes 有唔同 neutron， 所以佢重量會唔同。
Different neutrons. What is mean by different neutrons?
數量唔同。
Oh, different number of neutrons. So remember, so isotopes refer to the different atoms of the same element, which have the same number of protons, but different number of neutrons. So as we are going to talk about the mass, the main mass, it is mainly due to the presence of protons and neutrons. So that's why we have got the concept of mass number. Do you still remember? It is something about Form 3. And then because of that, of course, if you talk about different neutrons, so it will contribute more or less on the mass of the isotope. So of course, they do not have the same mass. How about second statement? Isotopes of an element have the same electronic arrangement. The answer, this is correct. What is meant by electronic arrangement? It comes from the concept of number of electrons. Number of electrons. So as we are talking about it as the same element, they have the same number of electrons. So of course, they should have the same electronic configurations. The answer is C. Okay? Do you still remember all those? You got it? Am I speaking too fast? Now, how about the next one? There should be 嚟揾值。
喺度。
Yes, chlorine 35 and chlorine 37 can be separated by the chemical means. These two have the different chemical properties. This segment.
Should be correct.
Should be correct.
喂，我細佬啊 ，sorry。
Okay, welcome to the chemistry lesson. So, but you have to speak in English. Right? Your younger brother, you have to speak in English. Can you manage to speak in English? Just left. Now, now, so can be separated by the chemical means. So could you please record the answer? Tell me again. Question 5. A can be separated by chemical means.
Yes.
You think it is A, right?
Yes.
Okay, but Yang Xinwei, you just say it as T. Now, it is totally opposite, right? D, A, or D is different. Now, I would like to listen to La Wanzheng. Okay, tell me your understanding.
Because 35 chlorine and 37 chlorine should have different masses, and I think that they have the different properties, but I think they have the different chemical properties, but the same physical properties.
Or same physical property, but different chemical property. So what is mean by physical property and chemical property? What is the difference? Can you give me some examples? No need to give me a definition, right? If you don't know, but the best way is to understand it is by showing some examples. Well, so for example, if you want to talk about boiling point is it physical property or chemical property?
Physical property.
Physical property. So are they the same? Now, what is mean by that? Now, indeed, it is quite different because you are going to have atom, right? So the best way is to tell you something like this. Cl2 is a gas, right? So we have got chlorine inside. We have got two combinations, right? We have got 35 and 37. Now, of course, we have got another combination, 35 and 37, or 37, 35. You talk about the same thing. Now, what I want to refer to you is about that 3 types of molecule, right? Now, if all those, we have got 3 gas jars, gas jar, right? We have got 3 type of gas. Now, in case we can separate it, right? Inside we have got that 3 gases. Are they having the same boiling point?
Should be no.
Should be no. Okay, which one is a higher boiling point? Which one is lower?
237 chlorine atoms.
Yeah. So indeed, that is the one. Now, how about chemical property? Chemical property, we have got that 3. And how to test the chemical property is to put a piece of, for example, it is the moist blue litmus paper into that 3 container. So what will happen?
The litmus paper changes color to red.
To red. Why?
Acidic property of chlorine gas.
Yes, that's right. Chlorine is acidic gas, but also chlorine is, also carry a property we call it bleaching. Chlorine is bleaching.
And the paper changes to white after it changes color to red.
Yes, that's right. Bleaching is a type of redox, so it can oxidize the dye inside the litmus paper. So that's why the blue litmus paper they will turn to red and finally turn to white very quickly because it's both acidic and bleaching. So what do you tell about that 3 cases? Now about the chemical property. So the first one, boiling point, we talk it is physical property. The second one is the bleaching. It is a chemical property. Okay, so whenever you talk about chemical reaction, it is chemical property. So take a look at that. These 2, they have different chemical properties. The answer is wrong. This is the same. So how is the same? It is identical. Okay, exactly the same. But for the physical property, we have got a slightly different physical property. So all of you could you please mark it. Okay, so this statement is not correct. Now, because of that, it is quite difficult to separate by chemical means. Chemical means you use some chemical method in terms of chemical reaction. to separate the chlorine 35 and chlorine 37. So this one is not correct. So the answer is D, but not A. You understand? How about question 6? How about question 6? Take a look on, thank you, Liu Wenjing. Good try, but Zhu Zhenfei, tell me, question 6. The relative atomic mass of iron is not the whole number. Iron has isotopes. Now, if in case you kind take and take, right? And B cannot explain as the statement 2 cannot explain as the statement 1, correct? Zhu Zhenfei, tell me the reason for statement 1. How to explain statement 1? The relative atomic mass of iron is not the whole number. It's not a whole number, which means we have got some number with decimal place, right? So what is the reason? Yes, I know that you may check on the periodic table. You know that iron, the relative atomic mass of iron is 55.8. It's not a whole number. So the statement 1 must be correct. Okay. So my question is, why? Now, if you think that the statement 2 is cannot use to explain statement 1, show me the correct explanation. You understand? So what is the correct explanation? Anyone who know what is the correct explanation? If Zhu Zhenfei has been suggested that B, the answer is B. The relative abundance. Yes, could you please average weighted number? Now, Cyrus, relative abundance, what is that? In calculating relative atomic mass, what you need to do? What is the way to calculate? You just say it as what average weighted number. What does it mean by average weighted number? Now, it is something about mathematics, right? It's not average value, it's not mean, it's not median. What is that? If we call that the weighted average. What does it mean by weighted average? Weighted average, not average rated number. Okay, so we call your memory about that. What is that? We call that the relative, let me put it here. The relative atomic mass. It is the weighted average, not average rated number, right? The technical term is weighted average. Weighted average means 加權平均. So what is mean by 加權? It is something like 按平均, right? So according to the proportion. So the proportion is the relative abundance. The relative abundance, right? So that's why I just asked you guys to think of how to calculate the relative atomic mass. It is the average of what? The relative isotopic mass of all isotopes, okay, based on carbon-12 scale. So that's why when you calculate this 55.8, you have to take it out how many isotopes are there, okay, and then you are going to get to know the relative abundance, and you do the weighted average. So that's why statement 2, right, we have got the isotopes with their own relative abundance. So the answer is A, right? This one is correct. Without isotopes, right? Without any isotopes, what will happen? Of course, we have got just one type of atom for representing that element. So whenever you pick, they have the same mass. So of course, if you present it as a relative atomic mass, it is a whole number. Do you understand? Better? Or still confused? Now, first of all, I just start from the first statement, which is in Form 3. Now, anyone who can, you think that you can still manage. Now, could you please put thumbs up? Show me your understanding. Down, you find that, wow, Form 3 stuff already forgotten. You still don't know what is that. Form 3 IS, right? Listen, you just tell me that you hardly remember. You remember some, but you cannot remember them all. Now, listen, get your turn. Your turn. Now, Pongkahu, you still remember? You know what is that? Now, listen, get your turn. Now, here comes the chapter 5. It is on atomic mass, atomic world. Now, here comes question 6. I would like to show you question 6 now. Wow, even more longer, right? A longer one. I would like to share with you again. This one. Can you see that? More answers, right? I would like to speed up the whole thing. Try to tell me your understanding. Now, I would like to split that larger, such that I can write something. How about this? Let me see which one is better for get to know. This one's better. And then, sorry, I need to at some point try to see is it better. No, I want to add more. Better? Yeah. Okay. Question 7.李俊傑, tell me. Question 7. Elements in the same period have the same number of occupied electron shells and outermost shells in the atoms. Statement 2, D is D. It's not correct. Could you please correct it here? How wrong it is? The element is the same period, show the similar chemical and physical property. I know it's D, right? So how wrong is this?
It should be same group. Same group.
Same
in
group.
the second statement.
Oh, you just want to change the word from period to group?
Yes.
If you write it down, is for same group, they will show similar chemical and physical property. Correct?
Yeah.
Similar chemical property, just like alkaline metal, right? How about physical property? Similar. So give me example.
For example, group 1 metal also low melting point.
Low melting point. You may find that it's quite difficult to further explain the term similar, right?
Yes.
Yes, it's very, very difficult. So I know it is wrong, but how to correct, you may find it is quite difficult. Now, take a look on the statement 1. Elements in the same period have the same number of occupied electron shells and outermost shell in the atoms. How wrong is this?
The outermost shell electrons are not the same.
Yes, are not the same, right? It depends on group number.
Yes.
It depends on group. So it is not correct. But for this part, if you stick back to the same group, but the concept of same group to further elaborate, right? Somebody would like to write it down as they do not have this, they have the total different, right? Physical, chemical property, starting from group 1 to group 0. Each one of them, they are very, very authentic and they are different, very different. So that's why we need to tell you something more about the periodic trends. Right, you know it. For the variation of melting point, boiling point in period 2 and period 3, you need and lots of words, right, to further explain and compare difference of those boiling point. Question 8. The density of calcium is higher than that of potassium. Calcium is a group 2 element and potassium is a group 1 element. Now it's very, very difficult now, right? You find it's more difficult to explain that statement. 魏卓賢，有得 Oh, first of all, A, B, C, or D? You think it is B? Explanation. You think it's B, but you need to give me your explanation. Wen Ziwei, good morning. Why are you so late? The time now is 10 past 9 already. Because it is irrelevant. Okay. Now show me your understanding about the explanation part. If you know it is irrelevant, you should have the explanation in mind, right? Density of calcium is higher than that of potassium. How is it related to the density? Now, Lun Xinwei suggests that the units of density, gram per cm cube. Cyrus think it as atomic mass. So density, you mean that density is something about packing, right? The packing of the particles. What type of particles are there in the calcium and potassium? I say that. Hey, Cyrus, tell me. You just give me a. How about what happened? You did not give me your explanation. I asked you guys to give me explanation. The density of calcium is higher than that of potassium. How will you know? It's by your observation, right? But what is the reason? HCl. What does it mean by HCl? Who just wrote it? HCl. You just compare the density of the two metals. How come you write down acid? What group an element belong to doesn't show whether the mass of it is higher. What do you mean by that? What group of an element belong to doesn't? Yes, just give me your reason first. I know the second statement is irrelevant, right? The second statement cannot explain the first statement, but tell me the explanation, please. You just escape. Two of you just escape from telling me the explanation. How about another Cyrus? Cyrus, are you with me? As I've asked you guys to show me your preference, are you here? Are you still here?
Yes.
Yeah, tell me statement. We are now doing a revision of Form 3 IS. Now take a look on that. The answer is B. Okay, I need to reassure all of you it is B. Okay, the group of an element, the position where those metals belong to which group, doesn't tell you anything to explain the density.
Period.
But you have to tell me the reason. And can you please try? Have a try on that.
It's about the packing of
Yes.
these.
Great. Yes, packing. Yes, that's right. Elaborate more.
I guess they're in different periods.
Periods. They are in different periods. Calcium and potassium. Take a look. Okay. Calcium and potassium.
Wait. No.
Same period. Yes, but different. What does it mean by period and group?
That's it.
Maybe you can refer to the periodic table, right? In exam, you can also use the periodic table to relate something. They are in different groups. Okay, one is group 1, the other one is group 2. So what's next? Yes, packing. It is something about packing. Now, as some of you have mentioned, the difference in packing on calcium and potassium. Once in a while, you still remember the different type of packing, right? Now, I know it is in material chem, okay? The content of it is something related to material chem. So what is the difference between the packing of the two? Right, this one, potassium, is a little bit more loose, and how about calcium? More close pack, right? So the type of a packing, you need not know it for the time being unless you want to study material chem. This is one reason. What other reason? It's just one of the reasons. Now, Wendy, could you please help? Calcium and potassium, they have different density. Besides packing, what else should be considered? Yes, that's right. The strength of metallic bond is different. It's different. So how different? What's the difference between the calcium and potassium? So you have to go back to the factors affecting the strength of metallic bond, which is the number of delocalized electrons released per metal atom. This is something about negative, right? How about positive? It is the metal cations. So you have to consider the size as well as its charge. Do you still remember those? Now I would like to write down here, right? Just if you have a nice revision here, right? And then plus, you are going to talk about the charge and the size of cations. So can you compare the two? Hi, Wendy, are you here? Yes, calcium will have got more delocalizations per atom released by when you compare with potassium. How about the charge and size of cations? You just write down the same. calcium ion and potassium ion, they have the same size. Do you mean that? Do you know why in this lesson we start to have the assertion-reason type questions, right? And do you know why I need to have a consolidation with all of you, revision? That is what you guys need to know, right? The size of cations. Well, so what is the form of the cations? Is Ca2 plus and K plus, right? So how many protons and electrons are there? Tell me. Because we have many misconceptions. I know, that's why. Don't worry. I'm not blaming that, but you have to tell me first. I just want you guys to clear all your doubts, right? And this one, calcium and potassium, we have got 18 electrons, right? 18 electrons. Agree? 2H, yes, that's right. The electron arrangement. How about protons? How about number of protons? The first one, calcium, is 20. The other one is 19. So what's the point of telling you, I'm asking the number of electrons and protons? Now, why and how does it relate to the size of cation? Size of cation. Now, the charge, of course, you know that calcium ion is a higher charge than potassium ion. How about size of cations? How to measure the size? Any definition? And definition of the to tell the size of ion. It is measured from the nucleus, the distance between nucleus and what? The outermost shell, the electron shell, right? So we will call that atomic radii, or for the metal you talk about ionic, right? So we have so the distance depends on what? Tell me, what does the distance depend on? It depends on the nuclear, we call that nuclear attraction, right? The strength of nuclear attraction. The attraction between something plus and something minus. Can you get the point? So which one have a stronger nuclear attraction? Potassium ion or calcium ion? Yes, that's right, calcium ion for sure. So that's why if you want to compare the size of calcium ion and potassium ion, you know that calcium ion will have a smaller size. But for potassium ion, a little bit larger. Can you get the point? So altogether, you will come up with all those factors that we will know that the more negative, the more number of delocalized electrons will have a stronger metallic bond. How about the cation? The higher the charge, the stronger the metallic bond. How about the size of cation? The smaller the size this time, the smaller the size, the stronger the metallic bond. Do you still remember? So that is the reason. That is the explanation part. Questions? Anyone who think that is better, right? It will help you better understand. How about this? Question 8. So please put a tick here. Still confused? Cross. Now, while we are waiting, I would like to invite some other people. Now, at least all of you here should contribute once, at least once. Who else? Lý Trật Trân. Lý Trật Trân. You are going to get ready for question 9. Neon, that one. Neon. Neon is used to fill electric light bulb. Can you see that question? And then the neon is an inner gas. A. A. D is because neon is inert, so it can be used to fill electric light bulbs. What is that electric light bulb? What is that? Tell me. What is electric light bulb? Right? I know that it is something very old-fashioned that don't know anything about tungsten light bulb now. You are most of you are now using LED. B. Help. Help. B. If you say that B, which means both statements are correct. 魏出現 Why you just say A? Now, first of all, tell me the first statement. I just draw it as a tungsten light bulb. Can you see that, right? We need to put a filling gas inside. So what is the filling gas? Cyrus, tell me, is it neon? So what is that? 魏出現 tell me. Come on. Just follow. Here is argon. Yes, that's right. It's argon. It's argon. So that which means statement 1 is correct or not correct? Yes, not correct. While neon is inner gas is correct. The answer is C. Do you still remember? So how come? How come in the past they will use argon but not neon? Do you know? Something about price, I must tell. Something about price. Now, because if you want to make a neon light, it would have a, it would be more costly. And in the past, while you use a tungsten light bulb is more widely used, right? At home, in industry, on some many places, right? But for neon advertising sign, it's just for advertising signs only. So you may know the demand is quite different. So of course, when you want to control the cost of making the light bulb, of course you need to get the linear gas as well as it is rather cheap. Okay, so argon among all other noble gas, it is the most abundant noble gas. You know it? It contributes about 0.9% of the air in the atmosphere. So that's why argon is a little bit cheaper when you compare with neon. How about question 10? I still insist on asking all of you. Just make sure all of you have answered once. Who else? Who else have an answer? Take a look. 徐家榮, your turn. H2O and H2S, they are both non-toxic. Oxygen and sulfur belong to the same group of the periodic table. 徐家榮, are you here? Tell me your understanding. Question 10. B, correct. Is it correct? Water is non-toxic. You agree, right? How about H2S? What is that? Hydrogen sulfide. Hydrogen sulfide is non-toxic. Agree? Both. Right? Can you see the word both, right? This one is non-toxic. Water is non-toxic. About hydrogen sulfide, sorry, is toxic. Oxygen and sulfur belong to the same group of a periodic table. Is the answer C? How about 11? Yuepam. The electronic arrangement of sodium ion is the same as cesium. Jiao Gaming, long time no see. The timeline is already 9:30. You are supposed to come back at 8:35. Jiao Gaming, you should be the first one to answer the question 11. Because you have got 1 more hour sleep, right? In which you will be more alert, right, when you compare with the others, right? You should have refreshed yourself very well. Question 11. Tell me whether it is A, B, C, or D. Not here. Jiao Gaming. You just enter it, but you didn't say anything. So what's the point of entering this? Yuepam, where are you? C. The electronic arrangement of sodium ion is the same as the cesium ion is wrong, right? What are they in common? They are in the same group, but they are in different period. So they have the same chemical property. Yes. So question 12. Boron and silicon belong to the same group of a periodic table. Boron and silicon are metalloids. Yuan Thiên Nhật. Yung Jing Nam, you get prepared for the next question. Yuan Thiên Nhật are you here? It doesn't belong to the same group, right? Boron belongs to group 3, silicon belongs to group 4. Just like form 3, I asked you guys to remember the 2 atomic number 5 and 14. Now boron and silicon, they are metalloids. The answer is C. Question 13. Carbon silicons, they are metalloid. Atoms of carbon and silicon contains the same number of outermost shell electrons. Yung Jing Nam. But we still have quite a lot of questions here, right? Up to question 27. You just stop at question 13. Still a long way to go. Liu Yong, where are you? How about another Leo? Leo Leung. Okay, metalloids. Now, carbon and silicon, they are metalloids. No, it's not correct. It's not correct. Carbon is not metal. Silicon is metal is correct. Now, but the whole statement is not correct. Atoms of carbon and silicon, they both belong to group 4. Okay, so this one is correct. And then cross and attack is a C. Bromine is more reactive than chlorine. For each group of a periodic table, the lower the element located in the group, the more reactive the element is. A very authentic questions. Very, very authentic. Okay, the answer is they are not always the case, right? Because the lower the element located in the group, the more reactive that element only applies to which group? Group 1 and group 2, right? They are metals, so they are different. Only applied for group 1 and group 2 metals. Now, the cycle repeats, 李健朗, helium and neon belong to the same period of a periodic table. And atoms of helium and neon have the same number of outermost shell electrons. You just write it down as C. That means the first statement is wrong, the second statement is correct. Agree? The first statement is wrong. It's not same period. It belongs to the same group. But this statement, it is wrong. The second statement is wrong. Helium and neon, even though they belong to the same group, they do not have the same number of outermost shell electrons. Helium, 氫氦鋰鈹硼. Okay, rank number 2. It's not octet, it's duplet. How about neon? We've got electronic arrangement to 8. So the outermost shell electrons number is 8. Yes, that's right. So I sincerely invite those Chem 1 students to take part in the Form 3 chemistry test. I've just uploaded the quiz to the students. I've just marked it. I do think it's a very good exercise, huh? Is it good if I return to Form 5 as well and try it? Jiu Gaming. Potassium is classified as group 1 element. An atom of potassium has run outermost shell electrons. Yeah? The next guy to answer that is yes, statement A is correct. How about question 17? 胡嘉倫, Manhei, you are responsible for question 18. 胡嘉倫, question 17. Magnesium and calcium, they have the same chemical property. Magnesium and calcium belong to the same group of the periodic table. Yes, the answer is wrong and take. How wrong is this? The first statement. Yes, the word the same. But they are not having the same chemical property. It is similar chemical property, but not same. In terms of reactivity, they are different, right? Calcium is more reactive. Question 18. Next guy. Who is the next guy? Manhei, 18. 温子偉, 19. 劉允正, 20. Okay. Question 18. Manhei, are you here? Is B. Across a period, second period of the periodic table from lithium to fluorine, you increase in melting point. Gradual increase in melting point. You just write down B, gradual increase. This one is correct. You think this one is correct? Agree? Across a second period of eruptive from lithium perforating to show gradual increase in metallic character. Increase. You also put it as a tick here, right? 問氣. So which one is the metal? Metals are commonly found on the left-hand side or on the right-hand side of the periodic table. What does it mean by gradual increase in metallic character? Which means on the right-hand side is becoming more like metal, while for the left-hand side, help. 18. 問氣. You better attempt the Form 3 chemistry test. Gradual increase is not correct, right? The trend of the melting point is something like this, right? Uphill, downhill, right? And this one, gradual increase, the answer is not correct. It is decrease. Both are correct. Both are not correct. Both are wrong. D. 19. Who just answered 19? 温志偉 19C. Take a look. The melting point of potassium is higher than that of sodium. It's not correct. It's lower, is it? The atom of the potassium is one more occupied electron shell than that atom is correct. It's C. But if you write down it's lower, can you give me the reason? 温志偉, if you make that statement correct, right? It is melting of potassium is lower than that of sodium. So what is the explanation? Yes, something about strength of metallic bond. So what is the difference? What is different? We've got three factors to consider, right? The number of delocalized electrons released per metal atom, the size of metal cations, as well as the charge. Yes, this time it's what? What's different? While the others, they are the same. Only this one is not the same. But this one, the difference in size has already contributed to the difference in strength of metallic bond. 20. Magnesium is the most reactive element in the group 2 of the periodic table. Is wrong. It's not magnesium. It's what? Something even downward, right? In the periodic table. That atom of magnesium has 2 electrons in the mole shell. Yes, reactivity of group 2 elements increase down the group. Good. 21. 陳俊熙朱俊輝李俊傑. The other 3 questions.雍正問咩? Good. Atomic size of magnesium is greater than that of sodium. Greater. Is wrong? It's smaller. Okay, the magnesium atom contains one more occupied electron shells than a sodium atom. 2H1, 2H2. The same. It's not C, it's D. Question 22. Next guy. 陳俊熙朱俊輝李俊傑. Question 22. Calcium is more reactive than potassium. Calcium atom has 2 other mole shell electrons about the potassium. Take a look. Just have 1. Cat. More reactive than potassium is wrong. And the calcium atom has 2 occupations. Yes. Question 23. 魏卓賢. Sodium ion and neon shows the similar chemical property because they have the same electronic arrangement. What do you think? It's not the same. Same electronic arrangement, I see. Four more questions to go. A very long lesson, huh? Hard time to me. Cyrus Yu. An ion of halogens carry one positive charge. An atom of halogen would attain the electronic arrangement of an atom of low gas when it loses one electron. Cyrus Yu. Halogen, what is that? Which group? Which group of element you describe it as halogen? Halogen, we call that a salt maker, right? Which means salt maker. A, B, C, or D? Ion of halogen, we will describe it as halide, not halogen ion, right? Halide, IDE. It is something negative, right? This one is group 7. Fluorine, chlorine, bromine, iodine, right? So the ion of that, it is anion. So we'll call chloride, bromine, iodide. It's not positive charge, it's negative charge. The atom of a halogen would obtain the electronic arrangement of the atom and it is not lose one electron, it's gain one electron. Wrong, wrong, the answer is D. Understand? You just have an answer. Most of you have answer, right? The last 3 questions. If you answer them well, right, that marks the great end of today's lesson. Question 25, 26, and 27. Sodium and magnesium ion contain the same number of protons. It's wrong. Okay, it's what we have got 11 protons for sodium ion and 12 protons for magnesium. You go back to atomic number, please, right? So that two have the same electronic arrangement. Is correct. Both they have got 10 electrons. So we have got to wait. It's the electronic arrangement for those two ions. Cross-tick is C. 26. The sulfide ion has a 1 more occupied electron shell than the sulfur atom. The sulfur atom gains 2 electrons to form sulfide ion. It's not 1 more occupied electron, so it's not correct. It has the same. So check that too. It is 2, 8, 8. Sulfur atom is 2, 8, 6. The same. Okay? Wrong. Take. Okay? So remember the gain is by gaining the electrons, cross and take. The last one. Group 0 elements are very unreactive. The outermost shell of the atom of a group 0 element is completely filled. (27) Yes, the first one is correct. A or B? Outermost shell of the atom of a group 0 element is completely filled. A or B? When it is completely filled, outermost shell is completely filled, what does it tell? It will have extra stability. So the answer is A, right? So that marks the end of today's lecture. It is about Form 3, chemistry. I will we just come up go overview for the first 2 chapters, atomic world and periodic table. And in the next lesson, we will continue on the bonding and structure. We will have got more assertion-reason type questions. I do think it would be better, right, to maybe I will post some to the web, to the Google Classroom. I need you guys to treat it as an exercise, okay? To treat it as an exercise, and you have to, speed up the whole thing, and you have to spend your time on drafting notes as well. What do you think about this lecture? I can do nothing, but you have to do it by yourself, right? Now, so the difference between I do it on the Google form and the other one is on the is during the lesson. Is for the lesson, I expect there will be some interaction, and I would like to listen to you more about the explanation. While you do the assertion-reason type questions on the Google form, you just check it as wrong or right or wrong only, right? It's just a checking of the answer. But the more I ask about the reason why, I would discover that some of you may have doubts, right, in managing the explanation. So, but if you want to achieve higher, and that skills must be highly needed. You have to get to know the concept behind clearly, such that you can choose the correct answer. It's not merely by your wild guess, right? It's not just by your sixth sense to tell me whether or not it's A, B, C, or D. So that's why I will still instead of having the lesson as list, and I would like to, because we are now having a revision, I would like you guys to be more outspoken in terms of written, or as well as or your you can turn on the mic and to tell me your thoughts. Can you get my point? Now this is my expectation on all of you in the lesson from this moment later on. Questions? Now, before you go, I would like to check your number, right? From 0 to 10. H258. Now, Yung Jeng Nam asked something about question 21, right? Question 21. The atomic size of a magnesium is smaller than that of a sodium. Okay, that one. The magnesium atom containing 1 mole is the same. Same occupied electron shell. You want to ask something about the question 1? Why? The atomic size of magnesium is smaller than that of sodium. Now, it is something about a little bit out of the syllabus. It is something about the textbook 5, the periodic pattern. You mentioned something about what? And the effective nuclear charge. It's a bit out of the syllabus. Okay. So it just tells you the net attraction. With considering the two factors, the first one is nuclear attraction. And the second one is the screening effect, right? The electron repulsion, in short. So when you come to from potassium to magnesium, okay, like this way, like this direction, we have got one, we add one more proton and one more electrons. Of course, they will have the both contribution to the nuclear attraction and the electron repulsion. But the extent of increase is different, which makes the magnesium will have a stronger net attraction and net nuclear attraction. So the concept is we call it as effective nuclear charge, but this one is OC. So for further details, you need to know is on the refer to textbook 5. And so what is the outcome? The outcome is the atomic radius across the period decrease. Do you know it? So this is what you memorize in Form 3 IS. Right, that is the periodic pattern. But the reason is something about this, right? It is quite rather difficult to comprehend for the time being. So I would suggest, you know it. So you suggest, I suggest you to read textbook 5 to get to know the details about the explanation parts. Okay. So you may find that it seems that quite a number of you you have got the careless mistakes, right? By overlooking some of the keywords. Even though you just mark it, your level of understanding rises up to 7 to 8. Just like naturally, you just mark it as 7. But every time you just overlook something. The understanding is one thing, right? The accuracy in answering the questions, the alertness of spotting those strange words, right? This is much related to the number of practice you are having. Is it a reflection that you lack practice? Sarah, a good reflection that you seldom do practice. Now, before I end up the lecture, I would like to check who were absent today. Quite a number of you absent. Can you please, anyone who has spot for me the absentees? Chen Weihao. Who else? Li Tong. Choi Junming. Who else? Jinghao. Or are they right? Oh, Peng Gao is Cam 2. So there should be one more. Who else? Could you please check it out for me? 5A and 5B students. Please check it now. I would like to check them well before I end up the lecture today. Oh yes, Lo Silva. Thank you. Chen Weihao, Li Tong, Choi Junming, Jinghao, Lo Silva. 5 of you. Okay. I will try to do a follow-up of those 5 students because we are now having revision, but you still didn't turn up. Okay, see you guys. Bye-bye.